There we went. Okay. That makes a lot of sense. Okay. And we're from this slide. This is example 8, but it's not the example 8 in your book. Okay? We did this one in class, didn't we? 2 cities on the map, that kind of stuff. The one in your book, example 8, is very similar, and that's where we're going to begin today. But before we do, any questions from anything we've done so far? Okay? Let me make a few reminders. Things to note. And part of the reason for this is sort of a bad news situation. Y'all have next week off. Okay, sorry about that. I had nothing to do with it. We have to work Monday, Tuesday, and Wednesday, but y'all have the whole week off. It's the same. It's just not fair. Okay. But anyway, that would give you a great time to get your papers done. Okay? Because out of my biggest class, started off with 32 students. Of course, a couple didn't show and a few have withdrawn. 2 papers have been turned in so far. And the month of November is rapidly coming to an end. That's the last chance to get your papers in. Okay? First quiz. We have 1, 2, 3, 4, 3 people who haven't turned in the first quiz, which would mean, of course, they haven't taken the first test. And that means also there are quite a few of the others who I don't know if you finished your test or not. So please get your first test completed. And if you have completed and you don't see a grade in Blackboard, let me know. I've got it graded, but I thought you were coming back to do something else. Second quiz, many of you have turned it in. We are coming up on the second test Monday when you get back from Thanksgiving. So quite a lot, well, not that much to do, but you get your paper done, get your quizzes done, and be ready for the test the Monday we come back. All right. Any questions before we go any further? Okay, I wanted to remind you of that because we're running out of term, folks. I think after we get back, I know there's 1 more week of classes. Are there 2 weeks of class and then finals? Or I can't remember. I didn't look at the calendar. Huh? 2 weeks and then finals? That's what I was thinking it was. So we're rapidly running out of terms. So please, copy. Okay. The example 8 in your book was, let me get my pen activated if it'll come up. There it is. It won't stay up there. There it is. Okay. All right. On a blueprint construction job, there's Kara. And there's Nathan. Okay. Finding you is the hard part here. And Nathan, at least you're right next to each other alphabetically. Good plan. Okay. All right. Any questions before we get going? Okay. And for those who just came in, Monday we get back from Thanksgiving. Okay. So be prepared. Bring your formula and equation sheet. All right, we're doing example 8 in your book. We did the example 8 on the slides, which was a little different. 1 in the book. On a blueprint for a construction job, 1.5 inches on the blueprint represents 15 feet in reality. Okay? If 2 columns are 2 inches apart on the blueprint, here's your columns, and the blueprint shows that they're 2 inches. You measure this with a ruler and see that it's 2 inches between the two columns here. You measured that. Find the number of feet between the 2 columns. How would you do that? Okay, set up a proportion. What goes where? Proportion. Say again now. Okay, 1.5 inches over Second? I can't hear you. Okay. I don't think so. Okay. Let me get. Okay. Just a second. Let me get. Got a fine frame. There he is. All right. Yeah. Okay. Okay. You could do that. That's okay. I wouldn't put the variable there, but you could put the 2 inches here. Okay. That's fine. Okay. What goes on the other side of the equal sign? 15 feet, and then the variable. And what do you want it to be? You choose. X. That's all. Strange that you would choose that. Okay, now. Why would I put it there, or why wouldn't I put it the other place? Okay. Okay. Good question. Okay. Now, you have 2 choices here, but you always have to get things to match up. Okay, you could either set up your first ratio as this many inches represents that many feet. So you could have put 1.5 inches as the 15 feet, but then on this side, you then have to put inches to feet. Now, she chose to go 1.5 inches to 2 inches. So if you did that, then you have to put the 15 feet that corresponds to 1.5 inches here, and the unknown feet that corresponds to the 2 inches there. You always have to have them, the things across the equal sign need to make sense, okay? If you have inches to feet here, make sure your inches to feet on there correspond to the same. If you have inches to inches here, make sure the feet on top corresponds to the feet on top here. And to put the X down here, that's no way you can get it, because 1.5 inches has nothing to do with that unknown distance, not anything directly to do with it. It has to do with either similarity in measurement or similarity in representation. It has nothing to do with that. Okay? So that's why you can't put that one there. Okay? There are 2 places you couldn't put it. You couldn't put it here and you couldn't put it there, because the X corresponds either to feet here or 2 inches here, has no correspondence to 1.5 inches. Okay? So it just could not go anything to do with the 1.5 inches, either across from it or below it. Okay. Good question. Now what? Okay. While I'm doing that, what's a little messy about the setup here? Yeah, it has a fraction, but it's worse than that. It's a fraction and a whole number. It's a mixed number. You need to go one way or another. Either make it a improper fraction or make it a decimal number, but don't have it mixed. Which way you want to go? Decimal? Okay, that'll work. What would that decimal be? 1.5 inches. Now I would do the cross multiplication. 1.5, you tell me, X is equal to 30. Okay? Now, I've taken off units now. We know that X is going to be in feet. Now, what do? Divide by 1.5. Now you have to remember how to divide by decimals. Of course, some of you are just going to pull out the old black box, and maybe it'll get the right answer for you, but you better know what you expect it to be. Okay, how do you divide fractions? You remember that? A long time ago. Decimals. You move that one place here to get a decimal out of the denominator, so you have to move this decimal one place too. Okay? What will that give you? X is equal to what? 20 what? 20 feet. Yes, this is a real life problem. You need to correspond. So yeah. Now you ask yourself, does that make sense? Well, 1.5 inches is 15 feet. 2 inches just a little more than that. 20 feet just a little more than that. That makes sense. Okay? I can buy that. Okay? Let's see how the book did. They got it right too. Good for them. Okay. They used D as the variable. It doesn't matter. They did change to 3 halves rather than 1.5. That works too. And if you had 3 halves, X is equal to 30, then how you solve that? Multiply both sides by 2/3. And when you do 2/3 of 30. 3 will go into 30 10 times. 2 times 10 is 20. Yeah, still works. Good deal. Any questions on that one? Okay, there's also an example 9. Let's see. They don't show example 9. So let's do example 9 elsewise. Okay. A sum of $750, I like that number, okay, is to be divided between two people. P1, P2, person 1, person 2. In a ratio of 2 to 3. What does that mean? What would you take it to mean? You don't take it to mean anything. You'll just take whatever they give you, huh? All right. What does it mean? Of those $750, this person say we get $2 for every $3 that one gets. That make sense? 2 to 3, the ratio. Okay? That's how we're going to split that up. Okay? How much does each person receive? There's the question. How much does each person receive? There's your question. What might be a variable? Make up a variable. X. Okay, good. Our favorite. Okay. What would you want that X to represent? Really, it needs to answer the question, or at least as much of the question as possible. So let X be what? How much what? Okay, well, just a second. No, that's not quite the right question. Let X equal how much, or the amount, that would be good. Okay. Pick a person. Okay, how much P1 receives? Right? Are you buying that? Okay. Now, without introducing another variable, we haven't done that yet. How do we come up with how much P2 gets? Yes, you got it. Because if P1 gets X dollars, P2 is going to be 750, if I could write, minus X. Does that make sense? Person 1 walks away with X dollars. P2 has what's left over. That's 750 minus X. Equal how much P2 receives. Okay, that's pretty lousy writing, right? All right, now, can we go from here? Okay, what? Okay, and what would you write? Okay, not just 750 anywhere. What's the, okay, X over. Okay, that's perfectly fine. X over 750 minus X. What's that a ratio of? That's 2/3 because person 1 gets $2 for every $3 that person 3 gets. Person 2 gets, okay? All right, you see that's the ratio. That's a legitimate ratio. You could have started with 2 over 3 is to X over 750 minus X. You match up person 1 to person 2. That has to be in there, okay? Now what do you do? And how does that come out? 3x when you go this way equals, hey, look at that, 1,500 minus 2x. Notice what he did there? Yeah, he multiplied at the same time. 2 times 750 is 1,500, 2 times minus x is minus 2x. Now what? How? Okay, what do you say do? Add 2x to both sides. That looks like a wiener to me, okay? What does that give you? 5x is equal to 1,500. What does that give you? All right. In his head, x equals $300. What's that? Yes, this $300 goes to the winner, number person 1. Goes to P1. Okay? Are you through? No, it says how much does each person get. So how do you get the second part? Say that again. Subtract that from 750, and what do you get? 750 minus 300 equal 450, and that goes to person 2. You've answered the question. Good deal. Does that make sense? Okay. Be sure you set up proportion to that it makes sense. 750 by itself doesn't go anywhere because that's not part of the 2 over 3. That's the total. Now, I was thinking maybe someone would say this, and it would have been fine. Basically, what you've done is broken this 750 into 5 pieces, haven't you? 2 pieces go to person 1, 3 pieces go to this one. So you could do it that way without doing a proportion. 5 will go into 750. What is that? 150 times? Yeah. And then two of those 150 pieces go to person 1, and 3 of them go to person 2. So it's another check. Yeah, that seems like it works. Maybe I didn't tell you all this. When I was in, say, grammar school, probably beyond that, junior high, probably a little bit even in the high school, if I ever had a math question, I went to my dad. He had been an ag engineer at NC State. He was a farmer, but he was an engineer, and he just ate up math, you know. So I would go to him and swear he could figure out a way to set up a ratio of proportions for just about any problem in the book. Now the teacher never showed it that way, but he made it make so much sense. I said, "What are they teaching this way?" I don't know, but you know this. Yeah. So a lot of problems you can set up, and they as long as you get the pieces in the right places, they're really simple to do. So, good tool, especially for you going into nursing when you have to do all those unit conversions, apothecary and metric and grams and milliliters and all that kind of stuff, body weight, you're going to be using ratios and proportions. Tay is here. All right, any questions on 4.6? There's a concept quiz at the bottom of page 4.6. The first 3 are true, false, well worth doing those. And then the next 2 look like they're you set them up whether they're proportions or not a proportion, okay? Then 6 through 10 is matching, okay? Good little concepts, questions that help you nail the concepts down. The answers are on page 223, so I would highly recommend you do those, mostly for fun, okay? The answers are right there. Then do homework exercises, any of the odds 1 through 43. There's a whole bunch of those. Do some of those easy ones, some of those that are a little bit harder. Then do 45, any of the odds 45 to 55. Okay, those are the word type problems. And be sure you do some of several types of those too. I think you'll see something like that coming up either on the next test or on the final. There are quite often, these are popular type questions to ask. 4.7 is a great section. We just don't have time to do it. But if you've got time, you might look at that. It just carries you a little bit deeper, just gives you more applications. So take a look at 4.7. Okay, then at the end of the section, there's a summary. We did 4.1 through 4.6. So on page 232, there's a bunch of summary, talking about some stuff, the rules, the principles, those kinds of things. A few maybe equations, formulas, that type of stuff, but that covers 4.1, 4.2, And 4.2 also goes on to 233. 4.3 begins on 233, goes, and 4.4 is on 234. 4.5 on 234 and 235. 4.6, bottom part of 235, and then you don't need to do the 4.7. But then for some reason, they go back and do more 4.5, 4.6 on page 237, the top half of the page. So you might want to take a look at that too. Then there's a review problem set. Now I believe these have, I think there's still odd numbers in the back. My book has them all. Do yours have odd or even for the review problem set? I know they have odds. I don't know if they have evens or not. So you can look at some of the odds, 1 through 5, 7 or 9, 11 through 23, 25, 27 or 29, 31 through 41, and 43 through 53. Okay? Any of those would be good to look at. Then there's a chapter test that's also in your text, and I would say you can probably do any of those, okay? And I believe all the chapter test questions or answers are in the back. I'm not sure. Again, my book has them all, but I think yours has all of the test questions. So those is another great thing to study for the test coming up Monday, okay, when we get back from Thanksgiving. All right. Then there's a cumulative review problem set. You can do those if you want to, but I see no reason. It has a lot of other stuff. All right, let's get out of 4.6, and we're moving on to 5. Oh, wait. Well, I did hit the wrong key. Now I got to start over. I get carried away if I'm not paying attention. Maybe it'll show up here. Have to go through this again. Any questions while we're waiting on this to wake up again? I guess I was talking too much and fell back asleep. That never happened, has it? Okay, never mind. All right, here we go. Now we're in chapter 5. Okay, and again, we'll probably only do maybe 6 sections or maybe fewer of this. Try to get as far as we can. At this rate, we won't even get it to open in time. Come on. Here we go. We're already recording. Let's just get the slideshow set up from current slide. All right, here we're talking about exponents and radicals. We've already been playing around and dealing a lot with exponents. We'll get a little bit deeper and do some other things with those. Inadvertently, when we jump to chapter 6 after doing chapter 3, we hit a little bit on radicals. Now we'll hit it in real life. I mean, full force. So that's what chapter 5 is dealing with. And we'll start in 5.1 strictly with exponents and strictly with using integers as exponents. Not anything more complicated than that. Hopefully you've done this before, and this should be a pretty quick review. We'll simplify numerical expressions that have integral exponents. And we have both Colton, Turner, and Peyton. Just got to find you in here somewhere. There you are. All right, has anyone else come in since the call roll? Good crowd today. Okay, then we'll simplify algebraic expressions. These are numerical expressions that have integer exponents. Then we'll do algebraic expressions that have integer exponents. Then we'll multiply and divide algebraic expressions that have integer exponents. And then we'll simplify some sums and differences. Multiplication, division, adding and subtraction. We'll simplify sums and differences of expressions involving integral exponents. So let's start. So far in this text, we have used only positive integers as exponents, right? X squared, x cubed, not too many beyond 2 or 3, but we have done some. Yeah, on that last quiz, you had quite a few that had higher ones. Now, the expression b raised to the nth power, where b is any real number in the world and n is any positive integer, okay, here's how we define that. B to the n would be b times b times b times b until you get n b's out there multiplied together. That's b to the nth power. Right? We've done that. Familiar with it? Any questions? Okay. Now, here's property 5.1, which, by the way, is at the sort of near the bottom of page 244. If m and n are both positive integers, and a and b are both real numbers, now, we'll have to have b not equal 0 if it appears in the denominator. Of course, we never put 0, just a 0 in the denominator. It doesn't work well. What happens if you're multiplying b to the n times b to the m? Let's think about what this is. This is n factors of b. 1, 2, 3, 4, 5. N factors of b multiplied by m factors of b. M of those. What do you wind up with? B to the, say again? Adding together. I couldn't hear what you said. You're absolutely right. Because you had n for factors of b to the n, m factors of b to the m. Now, when you multiply them, you got sum those up. N plus m. Okay? Now, shouldn't tell you this now, but I'm going to. So don't tell anyone. Okay? This works even if these are negative exponents. It still works. Okay? And what's even more amazing, even if they're fractional exponents, it still works. Decimal exponent still works. This works for any exponents. Okay? But don't tell anyone. We're only doing integers. Positive integers now. Works for negative. Okay. Now what happens if we do b to the n and raise that to the mth power? Okay? Give me a number for n. Pick a number. 3. So that's b times b times b, right? Now you're going to raise that to the nth power. Well, give me a number for m. Second? 6. Okay. That means we've got b times 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 b. You got 6 of those that you're doing. How do you figure out what that is? How many b's do you have then? Huh? Adding them? Don't think so. Let's do it again. Yeah, okay. Yeah. Here, when you're multiplying the bases, you add the exponents. Here, when you're raising a base to a power, you multiply the exponent. Now, you want to, I have a weird way of looking at this, and believe me, my wife tells me, but never mind, we don't listen to her. Okay. I picture our operations. The simplest operations are add, subtract. Then the next level up is multiplying and dividing. And the next level up is raising to powers. Don't put fractions. Fractions are so easy. Okay, no. Fractions are dividing. Okay, on the second level. Then you have raising to power and roots. Radicals and exponents. Okay. Now, when you're multiplying bases, that's on the second level. Same bases multiplying, you add the exponents. The exponents drop down one level. When you're raising to a power, drop down one level, and then you're either multiplying or dividing. In this case, multiplying the exponents. Because think of this. You have b cubed, that's what y'all said, b times b times b, raised to the 6th power. That means you have 6 factors of b's. You have b times b times b times b times b, okay? And when you do those together, it's 3 times 6, right? That's how many b's you got. So that's multiplying. Okay, how about this one? You got a product, AB, raised to the nth power. What do you reckon that is? to the nth times b to the nth. Exactly, because this would be, can I use 3 again for n? That would be ab times ab times ab. Well, that's the same as a times a times a. That's a to the third times b times b times b, and that's b to the third. So sure enough, that's what we got. Make sense? All right.
So on the last one, why you put AB to the N5 instead of doing A to the N, B to the
You can write it either way, whatever's easiest or most convenient that you see best. Exactly. Here's why I would most of the time go this way. Number one, you're clearing a parentheses so you can handle them separately. And then two, what if you were dividing by something that had a to the 7th in it? Then I can wipe out some of those. If it didn't have a b with it, then over here, I can't separate them until you do it that way. That's why I would do it. All right. There's property 5.1. Actually, oh, there it is. We had a couple definitions. The property 5.1 is on page 245, sort of near the bottom of the page. There were a couple definitions they didn't give us here. I think in the new edition, they've rearranged the order a little bit. So we'll come back and see those definitions in a minute. Okay? Whoa. Oh, wait. Here's some more of those properties. What if you're dividing a divided by n up b and raise it to the nth power? What would that be? A to the n divided by b to the n. Exactly. Clear the exponent, but you have to do the power in both numerator and denominator. Okay? How about this one? B to the n divided by b to the m. Okay? This has 3 parts to its answer. Okay. Now, give me a value for n. Make up one. 3. And how about m? 7. All right. Okay. Now you did it with n less than m. So let's go down here to this one. Okay. And what that means, you have b times b times b in the numerator, because you said n was 3. Down here you have b times b times b times b times b times b. 7 of those down here. So what does that leave you? These 3 wipe out 3 of those, leaving you how many? 4 in the denominator. So what they say is 1 over b to the m minus n. That's exactly what you did. 7 minus 3 is 4. Okay? Now what if we flipped them around and had 7 on top? B to the 7th divided by b to the 3rd. Now the b to the 4 is on top. Now it's n minus m on top. Okay? And what happens if they're both 3s or 7s? And it gives you what answer? 1. Exactly, 1. I just wanted to make sure you didn't say 0. Okay? It's 1. Good deal. So this is the case we do when m is either n is greater than m, equal to m, or less than m. That's how you do division on the same base, different exponents. And basically the same rule happens. Subtract the bottom from the top. The trouble is we haven't gone far enough to tell you what happens when that turns out to be a negative number. But or even when it comes up to be 0. Those were the 2 definitions they left off before, and maybe we should go back and hit them. I kept thinking they were going to show them. Now they do it, I think. Okay? The new edition doesn't quite match the PowerPoint. Okay? We're now ready to extend the concept of an exponent to include the use of 0 as an exponent and also negative integers as an exponent. I told you the rules still work. That's just my word for it. But let's tell you what that means. First, let's consider the use of 0 as an exponent. Does anyone know what that means? If 0 is your exponent. Have you run into that before? Okay. Yes, you did. You just did back here. Okay? And this one right here. Remember what we said? N minus m. if this n and m are the same, like both of them being 3, what does that give you? b to the third over b to the third is b to the 0, which is 1. Hang on to this concept, folks. Anything in the world raised to the 0th power is 1. Okay? 7,483,515 raised to the 0th power is 1. X to the 0th power is 1. Okay? 4/3 pi to the 0th power is 1. Okay? There's one exception. That's why I didn't want to really say anything. 0 to the 0th power is not defined. Okay? We don't mess with that. It doesn't make sense. Okay? But anything other than 0 raised to the 0th power is always 1. Okay? So, yes, let's consider the use of 0 as an exponent. Or to use 0 in such a way that we previously listed properties we can say. So, what if, and here's how they're starting this, we said this was true. What was that? B to the n times b to the m, that would be what? N plus m, got it. Now, what if that m was 0? Okay? The m here was 0. Okay? Then, that would be, and let's say n was 4. That's what they're going to use. What would you have as your answer then? B to the 4 times b to the 0 would be? Okay. Yeah, the second part, David, let's see, Josh Brown is here. Looking into the light, I can't read. Okay. So if you had x to the 4th, so n is equal to 4, m is equal to 0, using that rule, what would you have? B to the m plus n would be n plus m. That would be x to the, no, Adam. 4, exactly, okay? That would be x to the 4 plus 0, which would be x to the 4. Well, that's what you had over there. So what would b to the 0 have to be, if you started with x to the 4th, multiply x to the 0th, and you still got x to the 4th, x to the 0th has to be 1, just like we were saying. In order for that to be true, x to the 0 is 1. Anything to the 0th power, except 0, is 1. Okay? So, that then extends those rules we had before for positive integers now to include the integer 0. Same rules hold.
See, I was messed up. I was like, when I seen the x is 0, x to 0 power,
Yeah?
I said that's 1.
That is 1. You're absolutely right. So this would be 1. And what's x to the 4th times 1? X to the 4th. Multiply anything by 1, it's still the same.
Yeah, I would add them. You know, you add them two over there, the b,
You add the m and n's. You don't add the bases. To keep the base, add the exponents. And 4 plus 0 is 4.
You got 4x whole to the 4 power times x to the 1. That's 0.
No, that's not x to the 1, that's x to the 0. And x to the 0 is 1. The value of this thing is 1. And x to the 4th times 1 is x to the 4th.
So
Right.
the whole thing is 1.
The whole thing's 1. Exactly. Don't change the exponent. The whole value is 1. All right. Good deal. Good question. Good comment. All right. Now we get definition 5.1. They just changed the orders. I thought this was the case. This line of reasoning suggests the following definition. If b is a non-zero real number, okay, remember b now can't be 0 if you're raising it to the 0th power. It's the only value you can. B could be any other real number in the world. Negative 4/3 pi to the 0th power is 1, okay? Anything to the 0th power. Positive number, negative number, fractional number, decimal number, rational number, irrational number, anything to the 0th power, except 0, you can't have 0 there, is equal to 1, okay? So, what's 5 to the 0th power? What is 3/11 to the 0th power? How about x cubed times y 4th raised to the 0th power? 1, okay? negative 413 to the 0th power 1 into the 0th power 1, as long as n is not 0. X to the, oh, I'm sorry. This would be, these two things go with that, okay? On this one, x can't be 0 and y can't be 0 if you're raising it to the 0th power, okay? That's what these words go with that. This goes with that. No, this goes with that. They just got this a little screwy, okay? But it's all true. It's just out of order. Okay. Now, we can use a similar line of reasoning to motivate the definition for use of negative numbers as exponents. Okay? So, let's consider if we could do x to the 4th times x to the minus 4th, what would our rule tell us it would be? Okay? Now, x to the 4th times x. Same base, multiply different exponents, keep the base, x, and do what to the exponents? Add them. What's 4 plus negative 4? Say again? 0. And what's actually the 0? 1. You're absolutely right. Okay? How about this? B to the n times b to the m. What do you know that to be? N plus m, right? N plus m, right? Okay, we know that's true. Okay? Well, then as you said before, if you add these two together, you get x to the 0. Well, what's x to the 0th? 1. Okay, now wait a minute. You add x to the 4th to begin with, you multiplied it by something, and the answer was 1. What does that mean the something was? You add x to the 4th, you multiply by something, you get an answer of 1. What must that something be? The multiplicative reciprocal. Because x to the 4th times 1 over x to the 4th, those go out, and that would be 1, right? Well, that says that x to the minus 4th must be the same as 1 over x to the 4th. X to the minus 4th must be the reciprocal of x to the 4th. For this to work, it has to be, because the product is 1. And the only way you get product to 1 is if you multiply reciprocals by each other. Okay? So here's another definition. X raised to the negative power, that's this one. If n is a positive integer, this n, okay, and b is a non-zero real number, we're going to not have 0 as a base most of the time, then b to the minus n is the same as 1 over b to the n. All right. So let me give you my little rule on this. If you see a negative exponent, if it's upstairs, move it downstairs, lose the minus sign. If that happened to be downstairs and it was the exponent was negative, not the number, but the exponent's negative, move it upstairs and lose the minus sign. Does that make sense? No. Okay. Anytime that you have x to the minus 5, that's the same as 1 over x to the 5th. If this was in the numerator now, that would be over 1. Put it in the denominator, but lose the exponent. You lose the minus sign. Keep the number, but lose the minus sign. That's what's happening. 2 to the minus 4 would then be what? What would it be? 1 over 2 to the 4th. And what's 2 to the 4th? 2 times 2 is 4 times 2 is times 2 is 16. 1 over 16. There it is. Good deal. Okay? Make sense? Okay. Now that works even if the minus exponent is in the denominator. Move it upstairs. Okay? How about this one? What's 10 to the minus 2? 1 over 10 squared, and 10 squared is 100. You got it. Or you could write that as 0.01. 100. Okay? What would this one be? 3/4 to the minus 2nd power. What in the world would that be? Give me something to start with. There's several ways you can start these problems. 1 over 3/4 squared. Is that what you're going to say? That works. Okay? But what's 1 over 3/4 squared? What's 3/4 squared? 3/4 squared. 3 squared is 9. 4 squared is 16. That would be 1 over 9 over 16, right? Well, when you're dividing, and this is the dividing line, you invert and multiply, so flip those over. This would be 1 over 9/16, which would be 16 over 9. When you divide by something, you multiply by the result. So you flip it over. Now let me show you another way to work that one. This is perfectly fine because the same rules held as they did before. You could have written, well, let me get my pen on black. Okay, you could have written this as 3 to the negative 2 over 4 to the negative 2. Would you buy that? Okay, now, as I just told you, when this is a negative exponent, move it downstairs, 3, but lose the minus sign, squared. This is a negative exponent. It's in the denominator, move it upstairs, but lose the minus sign. And what's 4 squared? 16. And 3 squared? 9. You get the same answer. Okay? Now, let me show you one more way. Don't get confused with this, but it just shows you several ways. What you can do here is take the minus sign first, and that's going to flip what's inside. That becomes 4/3 squared, and that gives you 16 over 9. So there's a bunch of ways you can do this. As long as it's legal, you can choose any method you want to. This is fine. To me, it's awkward. That, to me, makes more sense. But if that makes more sense to you, do it that way. It doesn't matter. It can be verified, although it's beyond the scope of this text, that all of the parts in property 5, which I told you before, hold for all integers. Before we said positive integers, then we threw in 0. Now we're doing negative integers. In fact, it holds for all. And that's what I was doing here. B to the n over b to the m is still b to the n minus m. Whether n or m is positive, negative, fraction, decimal, it doesn't matter. They say all integers, n and m. So you could wind up with n being negative, m being positive, then it would be negative minus a positive, that would be even more negative. Or if n was positive and m was negative, that would be n minus a minus, which would be a plus. Very positive, yeah. And all sorts of iterations there. But you see, you've taken out of division and made it a subtraction problem. That's why exponents are pretty nice to play with. Okay? So we're going to restate property 5.1 again, as it holds for all integers, and include at the right a name tag for easy reference. Okay, if you like the name tag. Okay. If m and n are any integers in the world, positive or negative or 0, and a or b are real numbers, as long as you don't have the 0 in the denominator, okay, then, what was this rule again? B to the n times b to the m? N plus m, exactly. The product of 2 powers is the same base, sum of the powers. Okay, this one would be? Okay, you're taking from raising to a power down to a multiplication. B to the m plus n. Powers of a power gives you the sum of the power of the exponents. Okay? And then this one. Times b to the n, not the, it's times. And it's the powers of a product is the product of the powers. Okay? Pretty straightforward. I think there's some on the next page. Yep. How about this one? A over b to the n over b to the n divided by b to the n. The power of a quotient is the quotient of their powers. Okay, this one? B to the n divided by b to the m. Subtract the denominator from the numerator, exactly. So b to the n minus m. It doesn't matter what the signs are. Before we had to have 3 stages for that. When n was greater, when n was equal, and when n was less. Now we just do it 1. You don't need 3. It works for all of them. The quotient of the powers is the difference of the exponents. Okay? Having the use of all integers as exponents enables us to work with a large variety of numerical and algebraic expressions. Let's consider examples that illustrate the use of this 5.2. Okay? And I hope that's going to be example 1. Let's see if it is. Is that the same as the one in our book? I think so. Okay. You tell me what to write. 10 to the minus 3 times 10 squared would be what? Okay, right? Okay. What do you do if you're multiplying same base, different exponents? Yes, you keep the base, 10, and add the exponents, minus 3 plus 2. So that would be 10, and what's minus 3 plus 2? Negative 1. And what's 10 to the minus 1? No, it isn't. It's a positive number. It has a negative exponent. What does that mean? Where do we move it if it's a negative exponent? 1 over 10 to the 1, which is just 1 over 10. And that's a good answer, or if you want to write it as a decimal, what would that be? All decimals. We don't know our decimals, do we? You better. 1/10 is 1/10, okay? Same thing, means the same. All right, how about this one? 2 to the minus 3 raised to the minus 2. What would you do there? Oh boy, when they go from letters to numbers, that makes it really hard, doesn't it? Okay. What would that be? Keep the base, which is 2, multiply the exponents, which would be? Positive 6. Okay, got it. And then what would that be? 2 times 2 is? 4 times 2 is? Times 2 is? Times 2 is? Times 2 is? 64. That would be 64. Okay. 2 to the 6th power is 64. All right, how about this one? 2 to the minus 1 times 3 to the squared, the whole thing raised to the minus 1 power. How do we do that? Okay, keep the base of the first one, 2, and multiply those two exponents, this one and that one, that would be what? 1. So 2 to the 1 is 1. Again, with exponents, if it's a 1, you don't have to write it down. Okay? Times 3 to the, say again? Except it's a minus 2, isn't it? Okay, now what does that mean? I know what 2 means. It means 2. What's 3 to the minus 2 mean? 1 over 3 squared, and what would that be? 2 over 9. You got it. Very good. Okay, how about D? What would that be? 2 to the minus 3 over 3 to the minus 2 divided by negative 1. What would that be? Help me, help me. Say again? Okay. You only subtract if they're the same bases. These are different bases. So don't subtract. What we do, though, is the power of a quotient is the quotient of the powers. In other words, do that one first. 2 to the minus 3 raised to the minus 1 would be what? 2 to the third over 3 squared. And what's 2 to the third? 8 over 9. You got it. Good. Okay. How about this one? How would you do 10 to the minus 2 divided by 10 to the minus 4? Okay, that's one way you could do it. Here's what she said. The numerator would be 1 over 10 squared. That certainly works. The denominator would be what? Second. Okay, except it's already in the denominator, and 1 over that would move it to the numerator. So that would be 10 to the 4th over 1. Okay, now what? 10,000 over 100, and what would that be? 10,000. He likes big numbers, so I can tell he's going to be a banker. Okay, what would that give you? He doesn't like to divide by big numbers, though. Okay, what? That's go. Wipe out 2 zeros. 100. Okay, that's one way to do it. Perfectly legal. Okay, in most states. Okay, now how do we do it another way? Okay, let's take this and come over here. You could do this as 10. You got the same base dividing. You subtract the exponents, right? Negative 2 on top minus a minus 4 on the bottom, right? Doesn't that work? And what's 10? What's negative 2 minus a minus 4? No, wait. Negative 2 plus 4 is 10 squared. And what's 10 squared? 100. So there's several ways to get there, as long as you always take the right steps. Okay? You can do it multiple ways.
Why did you got 10 to negative 2 power, and you got 10 to negative 4 power?
Yeah.
I thought you were gonna subtract them when you add it.
No, okay, what you do, you start with the top of negative 2, and then add the opposite of the bottom.
Add the opposite of the bottom.
Yes, exactly, because you're subtracting a minus, which is adding the opposite. Yeah. And the opposite of negative 4 is plus 4, so negative 2 plus 4 is positive 2. Okay? Now that's how we did it. Let's see how they did it. How are we doing on time, by the way? 8 minutes. Oh, we got plenty of time. Okay. All right, the first one. Well, I didn't need to erase those. I thought they'd go right on the side. If you have the product of 2 powers, same bases, different exponents, keep the base 10, add the exponents. Minus 3 plus 2 would be 10 to the minus 1. 10 to the minus 1 is the same as? What? 1 over 10. And 1 over 10 is the same as? What decimal? 0.1. So that would be 1/10, or, oh, they didn't do the 0.1. You don't need to. All right, on the B one. Okay, where do we start there? Raising the power to a power, going through the right. Okay, what you do is keep the base, raising to a power multiplies the exponents. Y'all got this before. What does that give you? What does that give you? 2 to the positive 6. And do they write that out? Yeah, 64. Y'all got it too. Okay. Number C. All right. Now what they did, this is perfect. Yeah, this is basically what we did. We didn't write it this way. When you have 2 different bases, product of here raised to an exponent, that's the first one raised to that exponent, 2 to the minus 1 to the minus 1, times 3 squared to the minus 1. And what's 2 to the minus 1 to the minus 1? Why do you raise the power to a power? Multiply. So it would be 2 to the 1, which is just 2. And what would the second? 3 to the negative 2. So that would be 2 to the first times 3 to the negative second, sorry. And 2 to the 1 is? 2 to the 1 is? 2. And 3 to the minus 2 is? 1 over 3 to the minus 2. What would that be? 1 over 3 squared. Exactly. Move it downstairs and drop the minus sign. So that would be 2 to the 1 over 3 to the second. 2 to the 1 is 2, and 3 to the second is 9. So that would be 2 nines. Very good. What would 2 to the 0th be? 1. 2 to the 1th is 2. Okay, get those right. Okay. Let's look at D. Ooh, boy. If you have a quotient, different bases, raised to some power, raise the numerator to that power, but also raise the denominator to that same power. That's what they did first. The power of a quotient is the quotient of their powers. Okay? And what's that numerator going to be? How do you raise a power to a power? Keep the base, multiply the exponents. That would give you 2 to the positive 3 over 3 to the positive 2. So that would be 2 to the third over 3 squared. What's 2 to the third? 8 over 9. You got it. Good deal. E. That really, the last one really was one of the simplest ones. When you're dividing same bases, different exponents, keep the base, 10. Subtract the exponent. Negative 2 minus a minus 4. That's what they did. And minus, that would be minus 2 plus 4. That would be 10 squared. And what's 10 squared? 100. The way y'all did it was perfectly fine too. May have taken a little more work, but it still worked. Good deal. All right. They moved straight to example 2. Do we have time to do example 2? Yay or nay? What time is it? 4 minutes. Yeah, we can do this easily, okay? All right, what are we going to do first? Whoa, now we have, okay, what? Keep the base. What is it? X. And then you do what? Add the exponents. That's 2 minus 5. And what's 2 minus 5? X to the minus 3. Now it says here, express the final results without using 0 or negative integers as an exponent. That's a negative integer. How do I lose that negative integer? 1 over x what? Cubed. You got it. Good deal. How about the next one? X to the minus 2 raised to the 4th. What would that be? Okay, you keep the base, x, and multiply the exponents, which would be negative 8, but it says don't use negative exponents. So what would that be? 1 over x to the 8th. You got it. Good deal. How about C? What's that? Okay. How about C? What would that be? X to the negative 8th. Very good. Times y to the... not negative. Negative is positive 12. Okay, now I have one negative exponent and one positive. What do I do with that? What is? Okay, the different bases you can't add. Only if you say again. Okay, no, you got different bases. You can't add or subtract exponents. You just need to move one of the exponents. One of the powers. What do you do with it? The y/12th is fine. Leave it right there. Okay, but put the x downstairs to the 8th power. You got it. Now you got only positive exponents. Very good. Okay, how about D? A to the negative 6 over B to the positive 10. Now, you still got a negative exponent in one of the exponents. What do you do with it? Move it downstairs. So the A to the, not negative, You moved it down 6, and B to the 10th was already downstairs, so leave it there. Okay, he's living in the basement to begin with. Okay. Next. What would that one be? E. Say again? Keep the base. What is it? X. And do what? Subtract the exponents. That -4 minus a -2. And that would be x to the -2. But guess what? Still a negative exponent. What do we do with it? 1 over x squared. You got it. Bingo! Oh, you can't say that in Alabama. Let's just see if they got them right in the book. I think they did. That was 1 over x cubed. They got that one right. This one, they multiplied the... now, why did they do it that way? That's just totally nuts. It should be x to the -8. There's no reason to exchange oh, I see what they did. All right. These parentheses should be, I thought it was x there. Yeah, that's right. Why they put 4 in front, I don't know. But anyway, that gives us x to the -8. But to get it out of the minus, you put 1 over x to the 8. Very good. This one would be x to the, they do it in 2 steps. -4 to x squared to the -4th power times y to the -3 to the -4th power. The x, and again, they swapped the exponents, so I don't know why. 2 to the times the -4, -4 times -3. I don't know why they swapped the order. -8, +12. That'd be y to the 12th stays upstairs, x to the 8th goes down. Okay? This one, a to the, okay, they're splitting up first. A to the 3rd to the -2nd, B to the -5 to the -2nd. That would be A to the -6, that would be B to the 10th, and that then drops the A to the 6 down the stairs. Okay. And then this one's subtracting exponents. Keeping the base, subtracting exponents, and that gives you x to the -2, but that's the same as 1 over x. They did get them right. Good for them. All right. Let me give you just a few homework exercises in this section. Not many. Okay? Because you're going to be studying for your test as well. And working on your papers as well. Okay? Ooh, we got pretty far along here. Any of the odds 1 through 41. I think you can do those. And I think you can do any of the odds 43 through 61 too. Not very many. Huh. Okay. And we'll hold off on the rest of them until later. Good deal. Okay, I hope everybody heard. The test on chapter 4 will be on Monday when you get back from Thanksgiving. Don't eat too much turkey. Okay. Enjoy yourself. Eat all the turkey you want. Okay. Sure. Okay, just don't show it to anybody who hasn't turned it in. Okay. It was a really pretty quiz. I can't understand how you did it. Okay. Oh, yeah, you want to use it to study with, right? Okay. All right, it's out of order. What's that?
I read the paper you had online, so with on the paper, I can go through the book and find like anybody. You said I could do anybody in the book.
Oh, yeah. You mean as a paper
like a
topic?
person, yeah. I want to research a person, so I can do anybody I find in the book.
Anyone you find in the book, but anyone really that has anything to do with mathematics, you can. You don't have to stick with the book, but the book can give you ideas. Okay, you want to second page? Yeah. Okay.
Thank you.
Yes, sir.
I was just going my test, the test 1 hadn't been put in yet, the grade hadn't.
Okay.
I was going to let you can go and stick it in.
Put it in? Okay. All right, I'll do that in just a minute. I just found some of these out of order, so make sure I put them in order. Okay.
I was at work yesterday, ground with no safety glasses on. I got a piece of metal in my eye.
Oh, yeah.
It's still in the ground. I won't call, and I got to go to the doctor at some point today and get it
Yeah.
out.
I was working down in Florida. I had a meeting down in Florida, and the meeting was right next door where they were doing some construction, and on a big building, a hotel or something like that. I guess I don't know, a big building of some nature. And the wind was blowing really hard. And when we left the building that day, they were up there, and someone must have been grinding some metal, and one little speck of that went into my eye. Didn't even know it. Couldn't feel it. And that night at supper, my eye just was watering like crazy, but it hurt to rub it. I thought, what is going on here? That night, I was fine. It felt better. And when I went to go to bed that night, when I closed my eye, it hurt like crazy. So I was trying to sleep with one eye
Well,
open.
I had it happen to me before, and I should have learned my lesson by now to wear safety glasses when grinding.
Grinding. I thought you said driving.
Grinding.
Yeah.
But when I was grinding a while back ago, it happened. I didn't feel it go in, and then my eye just started watering like you did.
Yeah.
It started hurting. It was in there. It busted out 3 layers. But yesterday when I was grinding, I felt this and go in. It's still in now. I know it busted through 3 layers. I don't know. I gotta go to the doctor. I slept last night and my whole eye was throbbing.
Yeah, exactly. It was miserable. Then I had to go to meetings the next day with no sleep. I was supposed to be taking notes, and the lights hurt my eye like crazy. I don't know if yours is. And I was wearing sunglasses in the back of the thing. It was one of the worst days when I got back. I didn't know what had happened. I thought I had an ulcer inside my thing. I went to Eye Foundation Hospital, and they said, "Look, you got a piece of metal in there." Got it out.
It didn't take long to find it when you put that thing on there. He said, "You got a piece of metal in your eye."
Yeah, exactly. Yeah.
But it hurts.
Yeah, I bet. I've had it. Yeah. Yes, ma'am.
I have a question. For the research paper, I can do something that I guess I'm probably gonna do like measurements to deal with like
Do what?
measurements. I guess.
Oh, yeah.
To talk about how it like influences nursing,
Right.
doing certain things.
Sounds
But
like
is
a
that-
great
has
topic.
anybody done
Absolutely.
measurements?
I don't recall any this term. Yeah, so that's perfectly fine. Good topic.
Thank you.
Uh-huh.
I noticed on the research paper when I was looking at it said double space. Do you want us to like double space it or double space the lines? How do you?
Well, the whole paper is double spaced. I can't tell. That looks like that's close to double spaced. When the lines are real close together, it's single spaced. You know, on your word processing package, you know, you can see that double space. Yeah, just do it there.
Also, remember my grade was never posted on Blackboard for the test, but I took it.
Yeah. You want that final grade? I mean, I wasn't sure if
I
you're
don't
coming
even
back to.
know- Yeah, I don't even.
Huh?
I don't even know like if I did finish it or not.
Okay.
I just didn't know if.
Okay. Carol, right?
Yes, sir.
Okay. I didn't know if you still meant that or not. You still left one question without an
Okay,
answer.
well it's.
Go on and do it. Okay. So Colton and Carol. Okay. the two Carrols.
What was my grade on my final? I think you said you got the lowest one, but it's the lowest was final.
Okay. One more.
I think it's probably about
65.
okay. Well, it ain't too bad, I don't guess.
That's not. Okay. So you like the 65 down.
Yes, sir.
Okay.
So we're taking the next test on Monday, so be prepared to do that, and I'll get my paper trade. I'm almost done my paper, but.
What's that again?
I said, so we're taking our test on Monday when we come back for the
Right.
chapter 4. And be prepared for that, and you said definitely get papers turned in, which I'm almost done.
Well, no, okay. You don't have to. I'm just encouraging you to use the Thanksgiving break. Because after that, we're getting ready for finals. You're going to have less and less time to work on the paper. Yeah.
Okay. Well, sounds good.
All right. Good deal.
But we're in the middle of my eye.
Yeah. Go do it. No. Don't do that.